To execute field operations effectively, you need a reliable pipeline of information. But reality usually looks like this: disconnected emails for dispatching, physical paper trails for signatures, and manual end-of-shift data entry. Looking directly at this model, you see the bottleneck. Fragmented assignments mean dispatchers have zero real-time visibility, and reporting is entirely delayed. To fix this, we build a unified system. A single mobile app acts as the source of truth, pushing digital evidence straight back. Digital transformation relies on an automated, unbroken data pipeline, connecting the point of service directly to the manager's dashboard. We accomplish this by building an enterprise-grade field service microplatform, built entirely on the Microsoft Power Platform ecosystem. This diagram outlines the core architecture: strict separation. The Power App's front end on the left is completely decoupled from the automation engine on the right. Bridging them is a centralized data layer where both interface and workflows connect to a single secure database. To build this correctly, we follow a specific sequence: establish the relational schema, construct the mobile interface, extract the heavy processing logic, and engineer the application to withstand offline field conditions. Compromise on any one of these four structural pillars, and the application will inevitably break under actual enterprise workloads. The first and most critical engineering decision happens before you draw a single screen. You have to select the right backend database. This matrix compares the two options. SharePoint provides basic lists, but struggles with deep relational scale and requires manual coding for offline caching. Dataverse offers native referential integrity and built-in offline synchronization. For organizations deploying complex offline-ready operations, Dataverse is the architectural standard. Once the backend is selected, you map the schema. As you can see in this framework, the work orders table sits at the absolute center, storing only primary keys, scheduling data, and high-level job statuses. We avoid overloading that central table by isolating customer contact details and physical asset histories into their own tables. We then connect them back to the work order using simple one-to-many lookups. We apply the same strict rule to unstructured field evidence. Diagnostic text goes into an isolated service notes table, while photographs and digital signatures are captured as specific blob entities inside a dedicated attachments table. Enforcing this highly compartmentalized relational structure guarantees that the mobile UI remains lightning fast and that the resulting data is perfectly formatted for Power BI reporting. We now build the front end. Field workers operate in harsh environments, meaning the Canvas app interface must be thumb-friendly, high contrast, and devoid of complex menus. These wireframes illustrate the progression. A technician starts with high-level daily KPIs, taps their assigned job, and immediately drops into the specific work order details and asset history. To prevent massive data payloads from crashing the mobile client, we apply a strict security constraint. The assigned jobs gallery is strictly filtered by the current user's ID. They download exactly what they need and nothing else. When that technician needs to capture evidence on site, we rely on specific PowerFX logic. This code block shows how the app rapidly structures photographic data. Instead of forcing a cloud sync after every single picture, the clear collect function writes the camera's output to local device memory. The technician can snap multiple photos instantly without waiting for loading screens. Once the job is done, the patch function is utilized. This takes that local collection and securely writes it directly to the Dataverse attachments table in one consolidated action. Leveraging local collections paired with precise patch functions ensures enterprise data security without ever sacrificing the technician's operational velocity. The mobile application captures the data, but it should never process it. Heavy tasks like rendering documents or dispatching emails are offloaded entirely to a decoupled automation engine. Instead of complex app code, simple database row modifications act as silent triggers. As outlined here, updating a work order status to assigned automatically awakens a background Power Automate workflow that pushes an alert straight to the technician's phone. We trace a similar logic sequence for reporting. The exact moment a technician updates a job status to completed, a secondary flow initiates. Power Automate reaches into the relational database, aggregates the raw HTML notes, the asset history, and the image blobs, and compiles them into a single, highly structured service report. That newly generated document is instantly secured in a SharePoint repository. This storage action then triggers the final workflow to automatically email the customer the results. Structurally offloading the reporting burden eliminates hours of manual end-of-day administrative work, instantly freeing the field technician to execute their next task. This engineering assumes an active network connection, but field technicians frequently operate in basements or remote sites where silent app failures are architecturally unacceptable. Configuring native Dataverse offline profiles resolves this. By defining specific tables, the system enables conflict-free background data synchronization the moment connectivity returns, without requiring complex formulas. If your organization is strictly limited to non-premium SharePoint environments, you must engineer an optimistic UI fallback. This means utilizing manual load data and save data functions to cache collections locally until the network restores. Transitioning to data governance, the application requires granular role-based access control to prevent data bleeding across departments. The permission boundaries are absolute. Technicians operate on tightly filtered row-level views of their own assignments. Dispatchers require broad operational write access so they can dynamically adjust shift schedules across the entire workforce. Managers exist on a completely separate permission plane. They require unrestricted global oversight to monitor SLA compliance, approve system escalations, and track overall efficiency. Mastering offline caching patterns and enforcing strict, role-based data visibility separates a fragile citizen developer app from a robust enterprise deployment. Recap the complete architecture established thus far: a perfectly decoupled, highly relational, and mechanically resilient system designed to maximize field efficiency. Because the core relational data is properly structured, we can integrate advanced enhancements. AI Builder modules actively diagnose component failures from field photos. Furthermore, the work orders table bridges completed job data straight into legacy ERP systems or Dynamics 365 for billing. To safely manage this complex microplatform, strict application lifecycle management is a mandate. You must migrate this architecture safely across development, test, and production environments. This bespoke field service application doesn't exist in isolation. It sits directly inside the broader, interconnected Microsoft digital landscape, actively feeding intelligence to your workflows and reporting dashboards. This architectural blueprint establishes the foundation for scalable, interconnected ecosystems that permanently eliminate operational chaos.